Okay, hi guys. So we've got an example of some of the resolving stuff in action. We've got our buddy Fred, and there's two legs to his walk. He's walking northeast for 5 kilometers, and then he's walking on a bearing of 260 degrees for 6 kilometers. We're just going to draw a sketch of that first of all to get an idea of what his journey looks like. So I'll draw the two legs in two different colors. Northeast refers to exactly the northeast direction, the perfect diagonal between north and east. There's going to be a 45-degree angle when you compare it to the I direction. 45 degrees there, and then that is 5 kilometers. And then Fred has changed direction. He's going on a bearing of 260 degrees, 260. If I think about that in terms of bearings, I'm going from north. I need to go around here, and I think if I was going west, it would be 270. That's 270. So 260 is just going to be a tad below that. So it's sort of mostly west, but slightly south as well. Let's put that second leg in red. Have it something like that. And I'm going to need to move that line down a little bit so that it matches up there. There we go. And let's try and find an angle here. So the difference between 260 and 270 is 10 degrees. So that angle there, a bit hard to see. This angle here is going to be 10 degrees. I'll put that in on my diagram here. This angle is 10 degrees. And the length of this line, the magnitude is 6 kilometers. Now, if it looks a little bit messy for you guys, it might be worth drawing the two legs as sort of separate right angle triangles, and that might help you sort of see what's happening at each stage. Now, what we're going to need to do here is we're going to need to write down each part of his journey in component form. So that is, if you consider, oops, that should be black, 5k part of his journey, the first bit, we're looking at what this part is here and what that part is there. Then in the second part of the journey, we're doing the same thing. We're just breaking his journey down into how far did he move horizontally and how far did he move vertically. This might help out a little bit. To get these, I'm just going to use trig, so I'll blast through this a little bit quicker. We talked about the formulas earlier to get the adjacent and opposites. If I just rearrange these slightly, so for example, when we found the adjacent, we used cos theta is the opposite, the adjacent over the hypotenuse. And if you rearrange that formula, you bring the hypotenuse up, you can say that the hypotenuse times by cos theta is immediately going to give you the adjacent. Similarly, you could say that the hypotenuse times sine theta is immediately going to give you the opposite. So these will be quite useful to sort of speed the process up a little bit. The first leg of Fred's journey, he went 5 kilometers northeast. So in terms of breaking that down into a horizontal and vertical, if I do 5 times cos 45, that will give me the adjacent, which is the I bit down here. And if I do 5 sine 45, that will give me the j component. I should keep in mind here, because it was at a perfect diagonal, it was northeasterly, these values should work out the same anyway. So let's type in this on the calculator. I've got 5 sine 45, which is 5 root 2 over 2. as an approximation, that is 3.54. So I'll go for the approximation here. So we'll go 3.54. And I realize I've put that in the wrong place now, but it doesn't actually matter because it's an isosceles triangle. So this value is exactly the same as well. Here we go. So we've managed to split this up and say that 5 kilometers northeast is the same as going around about 3.54 in both directions. Now the second leg of the journey, now I will have to keep in mind here when I'm breaking this triangle up, is I'm going backwards in the I direction and I'm going backwards in the J direction. I'm going left and I'm going down. So both of these values are going to be negative. In terms of the I's and J's, I'm going to be able to get the I. This is adjacent to the angle, so this will work out as 6 cos 10. Move it across a little bit. And this length here will work out as 6 sine 10. Okay, so the I component is 6 cos 10. And since I'm going backwards, I will need to put it as negative. I can do that at any point. See what 6 cos 10 works out as. That is 5.90. I'll write that as minus now. This element up here is 6 sine 10. Again, since I'm going downwards, that's going to be negative, and that is 1.04. It's negative because it's going down. There we go. So those are the two individual legs. And we can write them in bracketed form if we want to. That's okay. Now, the resultant. So we'll encounter the resultant in forces when we get there. The resultant is just the result of the entire sort of journey. When we take the two individual legs, we have a look at where we start and we have a look at where we end up. So here's our start point. Here's our finish point. And we've done something like this in terms of displacement. So what we're interested in is finding how far did we go across from our starting point and how far did we go up from our starting point. Get that, we're just going to combine these individual components. So we'll add the I values together and we'll add the J values together. Let's do that. Add in the I values. We're going to have 3.54 minus 5.90. And that is minus 2.36. And the J's, I think that's going to work out as 2.5. Yeah, there we go. And just in terms of like matching up, like, does that seem right? We have gone left. I know our diagram wasn't perfect, but we have gone left compared to our start point, and we have moved up compared to our start point. So that looks pretty good. And finally, finding the magnitude and bearing of the resultant. This is like going back. We've got our components and we're changing it back into magnitude and direction format. So this is like what we did in the earlier exercise in 3C, I think it was. With this one, we're going to look at, again, our start position and our finish position. And we're going to make a triangle out of this. Let's just zoom in here. So we've got our start position. Roll that down again. Okay, so we started somewhere. The place that we ended up was roughly northwest from where we started. So we actually went 2.36 kilometers across to the left, and we went 2.5 up. So that's in terms of displacement. Obviously, the actual journey, we went 5 kilometers and then 6 kilometers. We traveled a lot further than that in total. We traveled 11 kilometers. But just in terms of displacement, that is how far we are away from our starting point. Finding the magnitude is finding the hypotenuse of this right angle triangle. So I'll put these numbers into Pythagoras. I'll have 2.36 squared, 2.5 squared. And let's just see what that is on the calculator. 2.36 squared plus 2.5 squared. And then I need to square root all of that. Is 3.44 to 2 decimal places, 3.44. So we're roughly 3.5 kilometers from our starting point, even though we did that sort of like weird zigzag shape. The other thing to do is to find the bearing. So they're not after the direction relative to I, they're after a bearing. Often when we're referring to compass directions, it makes more sense to use a bearing. So we want to know, if I'm traveling this way, northwesterly-ish, what bearing is that? We just move this around. Let's get rid of this for a second. So in terms of my bearing, the bearing is the angle starting at north, going all the way around up to here. And when we sort of think about that, so the 3 quadrants here, that is 270 degrees up to that point. Sorry about my colouring outside of the lines. It's not great, is it? And so that's 270 degrees there. Then that last bit just here, I can add that on. So what I'll do, I'll find this angle here using trig, and then I'll add 270 degrees on. The blue angle here. The opposite is 2.5. The adjacent is 2.36. I can use tan. I'll use inverse tan 2.5 over 2.36. Type that in on the calculator. It's the inverse tan of 2.5 over 2.36, and it's 46.7 degrees. So that's that angle there. So if I take that result, add on the 270, which is the bit in yellow, because remember it's a bearing. I add those values on, and I'm going to get a total angle of 316.7 degrees, and that is my bearing. Put it on the lines, shall we? There we go, lovely. Nice.